Hi, everyone. Here is a little reminder of what you did on remote day one this week. You had a few slides that talked about the special cases. Okay. So there are three types of solutions you're going to get when solving a system of equations. So the first is the one we're probably pretty used to seeing, and that's one where we have two lines cross and we get 1 point. Okay. The second is when you have your coordinate system and you have two lines that are parallel to each other. And there's no solution. In other words, there's no point in common. The reason for that is because parallel lines never meet. Okay, they're never going to touch. And the third is going to be two lines on top of each other, even though it looks like, now I'm trying it a second one, even though it looks like there's only one line there, I could give you two lines that still graph, that look different in the equations, but they still graph as one. Okay, so this is really when it boils down the same line, and this is going to be infinitely many solutions. I think there might be an E there. Infinitely many. Yeah, that looks better. And the reason why it's infinitely many solutions is technically all those points are touching. So if I took this as a line and I put my finger on it, I'm not just touching at one point, I'm touching at a whole bunch of points there, okay? And technically, if I keep getting smaller, there's infinitely many points that my finger would be touching, okay? Okay, so we can see those if they're graphed. So if you were given a graph, you could see which type of solution you're going to get. But what about if you're not given a graph? Okay, or how can you even save yourself time, right? If you knew that they're going to graph as the same, wouldn't it be amazing to only graph it once and not do all the work to graph two lines and then find out that they're the same? Okay, wouldn't it be nice if you could identify that the graphs are going to be parallel and say no solution because the lines are parallel? I know this because, however you know it. So let's look at that. So if we've got these different types of solutions, here are three equations. Okay. And so what we want to look for when we're trying to decide which ones of the things up top there are, what you want to look for is you want to look at the slope, and you want to look at the y-intercept first. Narrow it down if you can. So if I look at the slope here, my slope is -2, my y-intercept is 4, and my slope in this one is 1. Right there. Okay, so those slopes are different. If I look at my slope here, well, this one's 5. Oh, shoot, we've got a little something going on here. So it might be nice if I rearranged this. That may be one thing to do, but let's just identify them first. And for this one, well, these are not in the right order. So let's see what kind of work I can do. So now if I look at these, my slope is different. Let's just focus on number 1. My slope is different. And what's my y-intercept? 4. And my y-intercept here is -2. That means that's going to be your case 1. This is going to be the type of case that we've been looking at. Slopes are different and y-intercepts are different. That means those are going to cross at one point, okay? So that's going to be one intersection point. And you've got to do the work. Meaning you've got to do the work to find out where they're going to cross. What about number 2? Well, for this one, actually, if we think about it, really, it's number 2 and number 3. These are in different forms, and so it'd be nice to get them in the same form. So, well, this one's already in y-intercept. Let's go ahead and change this one. So I'm going to get y by itself. The good news is if you find you still need to graph them, you've already done some of your work and it's no problem. And if I divide both sides by -2, I see something. I get y equals 5x minus 1. Those are actually the same line, okay? So if they're the same line, they simplify to the exact same equation. What I end up getting is infinitely many solutions. Okay, and I don't have to do anything other than saying that. Okay. And then if I look at number 3, well, I look at this equation and I see this equation. Something I notice is 8 times 2 gives me 16. Is my coefficients over here the same? 1 times 2 gives me 2, and 1 times 2 gives me 2. Okay, well, so then if I divided all of this by 2, I actually get this equation. So now we have the same equation. We're in a number 2 situation, right? So this is the same line, infinitely many solutions. Okay, let's look at one more example. If I look at one more example, that's number 4. And I have, let's say y equals 2x plus 7. And what if I have y equals 2x minus 4? Well, what I notice about these is these have the same slope. These happen to be in y-intercept form. If they were not, you could put them in y-intercept form. But what I notice is they have the same slope. If you have the same slope, that means you have parallel lines. If the lines are parallel, that means that you have no solution. And the reason for that is parallel lines are never going to meet. So what I've done is I've just saved myself some work by noticing that. Now, what happens if with these 4 examples you didn't notice and you went ahead and you graphed them? Is that such a problem? Absolutely not. It's important to note the 3 cases and be able to identify them when you see them. It's a bonus to be able to identify the types given just the equations, okay? I hope you I hope this has been helpful, and if not, just feel free to reach out. Take care.